Okay, so inelastic collisions, let's try a few more problems and we'll use online simulator to check your answers and help you out a little bit with that. Even though it looks like the online simulator may not work, I'm going to show you some little tricks that you can use so that you can still use it. All right, so we have a situation where there's two railway carts and they're moving towards each other and they stick together after they collide. All right, and that's where you see the word stuck together. Okay, so we know that there's a 6,000 kilogram cart moving this direction at 2 meters per second. And then there's another cart and it's moving in this direction at 3 meters per second. And this is the before. And then after they hit, they stick together. So notice how I make it just like I did in the other problem. I make them stick together. And we don't know which way it's going to move. If it's going to be after they collide, if they're going to be moving this way together or moving that way together. A really quick check is simple. Look at the initial momentum of the first one. 6 times 2, 12,000. Let's look at the other one. 3 times 3, 9,000. This one has more initial momentum than this one. So therefore, we know that after they collide, they're going to have a resultant speed in that direction or velocity in that direction. So just like before, V1F is equal to V2F equals a common velocity of Vf. And this is for inelastic, only for inelastic type problems. Okay, what do we know? Well, we know that the total momentum initial equals the total momentum final. Now we do that little summation trick that the math that we looked at before with the summations. We only have two objects. So it's m1v1i plus m2v2i equals m1v1f plus m2v2f vectors. We're trying to find out what the final velocity is. Now we know that v1f is vf, v2f is also vf, so we just simply common factor, only for inelastic. So if we're trying to solve for vf, it's just the term we had initially divided by the total mass, like so. At this point, just substitute in our values. So it was 6,000 times 2 plus 3,000 times negative 3. Oh, it's important up here. Pick a direction to be positive. Okay, that's really important that we have a direction to be positive. Okay, oh, I just smudged it. All right, so that's why that's negative 3. And then the total mass is 9,000. Plug that in our calculator and we get 0.33 meters per second. Of course, since it's positive, that's to the right. Okay. Now, what some of you might be saying is, okay, it says check with these simulators. So let's see how we do that. Okay, here's the simulator. And we can set the speeds. Now I'm going to initially set these guys close together because they're going to be moving really slow. It says set this speed to 2. You might be able to change it up here. No, you got to drag it. Okay, 2, and this one's negative 3. There we go. Now the mass. One is 6,000, one is 3,000. So if you divide both by 1,000, it's really 6 to 3 is the ratio. And that's all you really need to do is look at the ratio. The ratio is 2. So I could have chosen any value. It doesn't matter. I could have chosen as long as it's a 2 to 1 ratio or a 6 to 3 or 6,000 to 3,000 ratio, you'll see that this will always work out to be correct. So you can use the ratios of it to figure it out. They move, slow, 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 and boom, they hit. And now they're moving really slowly to the right. You can't even tell. But 0.33, exactly what we found. Okay, now let's take a look at the second problem. Okay, in the second problem, we now have a car chasing another car, and the one car rear ends the other car while they're moving. And so the situation looks like this. We've got an M1. It's moving at 20 meters per second. Got an M2 moving at 10 meters per second. They hit. They stick together. They have a common speed. Obviously, they're going to be going this way. I think anyone can tell that. Now, the speed's going to be somewhere between 20 and 10 when they hit. And in fact, it tells us that they hit and they're moving at 12 meters per second. Now, that right away should tell you something about the size of mass 2. If they slowed down from 20, if the one car went from 20 down to 12 and the other one went from 10 up to 12, sorry, this changed by 8 meters per second negatively. This changed by 2 meters per second positively. That means that this one felt the impact way more than this one, which means that this one is likely to be significantly more massive than the other one. And that's what we're going to see now. You might even be able to start thinking about ratios and see if you can think about what that solution might be. But let's write it out. And if we write it out, we know that the total initial momentum is equal to the total final momentum. M1v1i plus M2v2i Okay, and since they are combined, we're going to skip that all and just say that we just know it's we can common factor it. Oh, actually, we don't want to do that because I think we're trying to solve for M2. And since we're looking for M2, common factoring is not what we want to do. So we're going to ignore that part, and we're going to bring the M2s to the same side and the other stuff to the other side. So V1I, M1V1F, now we common factor because we're looking for the mass. And we write our final solution. There we go. Again, pick a direction to be positive. Just pick it to the right. Substitute in our numbers. 1200 times 20 minus 1200 times 12 all over 12, and V2I was 10. And so we're at our last point here. If you put that into your calculator, we end up with 4,800 kilograms. And notice the solution. 4,800 is compared to 1,200. The ratio is 4 to 1. So it's a 4 to 1 ratio for that. And yep, and that's how you can tell that it would slow down so much. Now, how does that work on the app? Well, let's check the app out and see what we can do. So now I'm going to reset this, drag them kind of close. One is going to be moving at 20. One is going to be moving at 10. We know the mass of one. We could just make it 4. And the other one is just 1 because it's a 4 to 1 ratio. We could have done whatever you want. You could do 48 to 12 if it would allow you, but I don't think it would. And it's inelastic, and the solution when they hit had hopefully better be 12. and it's 18. Oh, because, let's reset that, 20. I had it backwards. They hit the other way. I made the heavy one hitting the lighter one, which is why you saw that solution. But it was easy to realize that quickly. There we go. Oh, that's the hardest part. This should be 4. And this should be 1. And there you go. 12. Exactly what we got when we were looking at the solution. Okay. So it came out to 12, which is what we had expected. All right. Let's take a look at the next one. Okay. So now there's these are simple elastic questions, and so you're going to do the same thing that you did with the other one, and you're going to check it with the simulator exactly like we did. These are simple elastic because they give you all of the possibilities. Okay, there's everything that you need. So 2 carts are moving. I'll set it up and you can finish it. Cart 1 has a mass of 5 kilograms and moving to the right, so it's moving this way at 40. Cart 2 has a mass of 1 and it's moving this way at 10 meters per second. They're going to hit and they're going to be moving afterwards. And we're going to see what the solution. Cart 2 has a mass of 1. Okay, after the cart 2 is moving at 73.33 meters per second this way, and calculate the speed and direction of the first cart. Okay, so the first cart hits, so it's doing 40, and then the other one's moving towards it at 10, and they hit, and it says this one flies off at 73.3 meters per second. And I think the masses were 5 kilograms for the first one, so this was 5 kgs, and this is 1 kg. And we're just trying to figure out what that this V1F is equal to. Now what's neat is you can skip right to this track here. You can reset it, and you can give it a shot. You can change it to elastic. You can set this to 40. Okay, and you can set this to 10, -10, like that. The masses are 5 to 1. So cart 1 is 5 to 1 ratio. So it's a 5 to 1 ratio. Let's see, they hit. And there you go. So that bounced off a lot. It changed its momentum a ton. You don't want to be in that car in that situation. That's like a bumper car situation. You got hurt. This car here just barely, it just slowed down. It went from 40 and dropped to 23. This one went from -10 to 73. That's a change of 83. That's huge. This one only changed by 17, right? And so that's why you'd want to be in this one and not in this car if you had to be in one. The inertia, the neck snap you would get would be bad. So you just go to your solution and you just start working through. You just put in PTI equals PTF like this. Now you can't combine those speeds because they're not moving at the same speed afterwards. And all you need to do at this point is pick a direction to be positive. Let's make the right positive. Rearrange the formula, plug in your values, the proper signs, positive and negative signs, and get your final, your V1F. That's all you're solving for in this case, is this guy right there. Okay, you can do the same thing for the next one. And this one you're trying to calculate the mass of cart 2, pick a direction, make your diagram, and answer your question. All right, good luck.